this failure mode and effect analysis is going to help you to do this risk analysis. So there is risk everywhere. Okay, without risk, it is not possible to run any system or process or any equipment. So, but the impact of risk must be minimized. It should be under control. That is what we are trying to do in this process. Okay. So what we are going to learn in this FMEA tool. So it is a very, very, very critical, significant tool. So we are going to see what is Six Sigma and why it came into use and when it can be used. And we are going to see what are failure modes. So without knowing the failure modes, we won't be able to find out the risk and the failure impact. So we should know what are failure modes, and then we will know how to conduct this FMEA. That is very important part of this session. And then how to apply this FMEA, we will see for a process and we will see for a small component also. So before going into this tool, we should know some of the top terminologies which are being regularly used. The first one is, all of us know, FMEA, that is failure mode and effect analysis. Okay, that stands for FMEA. Then a risk priority number, that is very critical, RPN, risk priority number. This is very, very, very critical, important in this FMEA. So we are going to calculate this RPN. Then action priority. So we have 10 risks identified. Which one has to be given most importance at that moment? That is action priority. We will look over that. Then we are going to see two important associations which are responsible for developing and implementing throughout the world in automobile sector and in other industries. One is AAG, that is Automotive Industry Action Group, and another one is VDA, Verban der Automobile Industry. These are automobile industry associations. They are responsible for implementing this particular FMEA in all industries. Okay, especially in automobile industries. Okay, what is this FMEA? How it came into use? See, earlier it was used by NASA. All of us know National Aeronautical and Space Association of America. They developed and applied this for their space launching vehicles in the 1960s. So it is an old tool, nearly 6 decades old. In the 1960s, it was used by NASA. Then it was moved to US Navy, and it was developed as a military standards 1629 in 1974. And after that, it slowly sneaked into the industry because of its effectiveness and efficacy. It slowly sneaked into the industries in the earlier stages by automobile industry, and after that into all industries. Okay, so that is how this FMEA came into effect. Then important thing you must know, it is an analytical methodology. That is, we used to calculate some, put some values and calculate the numbers. Okay, analytical methodology through which we identify. Okay, first step is we will identify the risk. Okay, then we will quantify the risk. That is, we are going to give some numbers, quantify the risk, then prioritize. Okay, so out of 10 risks, which one has to be given importance? Okay, for example, we may have we took a two-wheeler. We are starting the two-wheeler. There is a brake failure and there is a odometer failure. Which one we will give importance? We will give importance to brake failure. That is prioritizing. So this FMEA will help you to prioritize and evaluate. Okay, what is the impact of this risk? Okay, what is the impact of odometer failure? What is the impact of a brake failure? We will evaluate the risk. That is what FMEA does: identifies, quantifies, prioritize, and evaluates the risk. Okay, and another important thing when it comes to process or system, it helps you to identify the weakness in the system. That is important. If an organization wants to grow, it has to find out the weakness, it has to find out the threats, then only it will be able to move to the next level, reduce the weakness or reduce the risk. So it helps you to identify that. Then potential defects. See, we are very keen about this vulnerable defects, potential defects, which will affect our system, which will create a gap in our performance. So we have to identify that. FMEA will help you for that. Then it recommends corrective actions also. So this is what the FMEA can do in our Lean Six Sigma process. As a Lean Six Sigma Green Belt expert, we should know this thoroughly. Okay, so why we need to use this FMEA? What is the purpose? See, first, it helps us to keep track of potential failures. So if we identify the potential failures, then we can reduce the risk of disaster. Okay, so that is the first thing what FMEA is used for. You can identify, you can quantify, you can prioritize the risk so that we are able to eliminate the impact of the risk. So first keep tracking of the risk, then always we are happy to say in industry that prevention is better than cure. So prevention is better than investing money for failures. So we try to prevent risk, we try to prevent failures. The FMEA will help you to do that. Then for regulatory purposes, so we have standards. Wherever we go, we have industrial standards followed throughout in all industries, safety standards, environmental standards, manufacturing standards. So FMEA also became a standard so that industry has to follow them. It is a mandatory for them because it deals with risk, it deals with some fatality. So we will know that in the coming slides. So this is why FMEA is highly recommended and frequently used by all industries. So when it comes to classification, FMEA has two major classifications: design FMEA and process FMEA. In design FMEA, if you start a FMEA process in the design stage itself to identify, to foresee failure modes and rank them even in the design stage and try to reduce the risk, that is called design FMEA. That is, we try to find out the risk failure involved in a process in the design stage itself. Okay, we have to put an allocated team for that and they will be doing this process. Okay, that is called design FMEA. Then what is process FMEA? See, if you are identifying a risk or potential failure modes in the existing system, in an ongoing system, okay, and we rank the failures and prioritize them and try to evaluate them and try to reduce the impact on them. That is called process FMEA. Okay, so in subclassification is, we can go for equipment FMEA and we can go for maintenance FMEA, service FMEA, system FMEA. That will defaultly come under the process FMEA. So these are the two main classifications of FMEA which we must know: design as well as process. So in a Lean Six Sigma, as a Lean Six Sigma expert, we must know when to use it. You can use it in the analyze phase, you can use it in the improve phase, you can use it in the control phase. In the analyze phase, we use to determine whether there is a high risk of failure or it is just a poor detection of the failure. So in analyze phase, we can use it for detection of high risk, and in the improve phase, we can use to evaluate the solution. So we are going to find out a solution and try to eliminate the problem or try to eliminate the impact of the problem which we have identified in the previous phases. So this FMEA will help you to evaluate the impact of the proposed solution which you are implementing. Okay. Then in the control phase, to determine which failure modes are critical. So after implementing the solution, still there is a possibility of failures. So we have to do it in the control phase also. It is a cyclic process. So it will help you to find out whether there is any failure modes available in the process again. So this FMEA can be used continuously in this Lean Six Sigma process. Okay. So as an expert, we should be aware of this. It can be used in the last three phases at any time. So before going into the crux of the FMEA, we should know what is failure modes. Okay. Can anyone of you say how this online class can fail? Can anyone of you say one failure mode for this online Lean Six Sigma training program? Anyone of you? I see a lot of people interacting. Yes.
Maybe connectivity if it fails.
Very simple. If the internet connectivity is poor, the system, the online classes may not happen. It is a failure mode. Suppose if my laptop doesn't have power, the process may fail. If my laptop is not working properly, my process may fail. Okay. Suppose if I am not available at this time, my process may fail. Suppose if the Zoom doesn't work, the process may fail. So suppose if your internet connectivity fails. So these are the failure modes for this particular online session. So we have to find out the possible ways, all possible ways a system can fail. So when we are going to analyze the risk in the analyze phase, we should know what are the possible ways that this system can create failures, that the system can fail. Then only it will be easy for you to do FMEA. So the strength of FMEA is in finding all possible failure modes. We should not leave even a 2% failure mode. Okay. So sometimes multiple failure modes are available. Okay. Sometimes if the system is too complex, you can get more failure modes. If the system is simple, okay, the failure modes will be simple. If the system is complex, this failure mode will be complex. We will see that with an example. See, for example, take a home fire alarm. Can any one of you say what will be the possible modes of failure of a home fire alarm? Can any one of you? A home fire alarm, which will be operating in battery or electricity. Any one of you? You can unmute and say.
Battery is down.
Very simple. If the battery is down, the fire alarm won't work. Okay, very good. Then anyone? Suppose if the connectivity, which is given, the circuit connectivity given, if it is wrong or if it fails, then also the home fire alarm will fail. And suppose if the sensor, if the detector which is in the home fire alarm, if it is not detecting the smoke, or the temperature sensor which is installed, if it is not detecting the rise in the temperature, then also the home fire alarm may work. So these are simple, this is a simple system, and so we are able to identify the failure modes easily. Suppose if I'm asking you to find the failure modes of an aircraft, the system is quite complex, right? So the failure modes also very high. So if the system is simple, if the system is very normal or a simple one, the failure modes will be less. It will be easy for you to analyze. If the system is complex, then you have to find out more failure modes. More failure modes will be available. In the case of aircraft, you can see at least 15-20 main systems will be there, and apart from that 30-40 secondary systems will be there, and all the failure modes in those things has to be analyzed. Then only the flight will be less risk. It will be less risk for the pilot to operate and the flight to fly in the sky. So depending upon the type of system we are going to analyze, the failure modes will vary. So let us see what are the steps involved in the FMEA. See, first and foremost thing which we must remember is we have to identify all probable failure modes present in the system or in the process or in the equipment. Then we have to find three factors. One is severity. Okay, on the bottom you can see one is severity, another one is occurrence, and the last one is detection. You should find these three factors present in that particular failure mode. Okay, we will. So what is severity? See, for example, if a brake fails, what is the severity? For example, I am going to give you a rank 1 to 10 for different kinds of failure. For a brake failure during driving, what kind of number you will give? 1 is
10.
minimum, 10 is maximum.
10. 10.
Yes, 10. Because you know it may create a disaster, it may be fatal for the driver also. So in that case, you are giving a severity rank of 10. What is the chance of occurrence? Whether it will occur regularly or
Very
rarely, very low. So in this case, you can give a low rank, 1 or 2. If the chance of occurrence is frequent, then you can give 8, 9, 10 like that. Then the third one, detection, whether I'm able to detect it certainly or if I'm not able to detect at all. Okay, then based on the ability to detect in advance or based on the certainty to detect, you can give rank from 1 to 10. If I am able to detect certainly, I can give a rank of 1, 2. If I am not able to detect at all, I am able to know only after it happened. For example, take an earthquake, whether you are able to detect it in advance, impossible. So you can give a rank of 8, 9, 10. If I am able, whether I'm able to detect a storm, yes, I am able to, government is able to detect, the IMA is able to detect the coming of a storm 2 weeks before itself. Okay, so you can give a rank of 2, 3 like that. So these three factors will help you to find the RPN. So if we multiply these three factors, if I have to give rank for these three factors, that is severity, occurrence, and detection from 1 to 10, depending upon the severity, occurrence, and detection. Then I have to multiply all these three. Then I will be able to get a RPN. So calculation of this RPN is important. You multiply severity, occurrence, and detection. So suppose if I am having 10 risk in my process, I will calculate the RPN for this and I will rank according to them. Okay, the one which is having a high RPN, so normally it will be within 100. Okay, so suppose a particular risk may have 95 RPN of 95, another may have 96, another may have 80, 75, 60 like that. So I have to prioritize according to the rank. So now it will be easy for me to focus on the risk which has to be given more importance. So this RPN will help for that, but it doesn't end here. We should sometimes if the RPN scores are same or if it is very close, one is 95, one is 96, one is 97. Which one will you give more importance? For that we have an action priority table. We will look that also. So this potential failure modes can be controlled by finding this RPN. Okay, so the RPN will be normally within 100. Okay, depending upon the type of design or type of process which you are choosing, you can select this RPN. Okay, you can select the values of RPN which you have to give more priority. So after finding this RPN and you have done some corrective actions, again also after implementing the corrective actions also, you have to do this FME again to check whether the RPN value has come down. Okay, so this is how the three factors are scored. Okay, if it is less severe, you give rank will be within 1 to 3. If it is very severe, it will be 10. Then based on the occurrence, if it is very likely to happen, your rank of 8, 9, 10. If it is moderate, 4, 5, 6. If it doesn't occur, if it occurs rarely, give 1 to 3. You are able to detect easily, then give 1. If you are not able to detect at all or very rarely you detect it, you give 7, 8, 9, 10 like that. Okay, so this is how the severity rankings will be. Okay, so for example, you can see if a particular risk, if it affects the operator without warning, okay, a failure of a brake will affect the driver without any warning, right? Okay, so we are going to give 9, 10 like that. If there is, for example, a odometer indicator, suppose the indicator fails in a two-wheeler, whether it is going to affect the operator? No. So very minor or minor effect. So we give 1, 2 like that. So likewise, you can give for process FMEA also. Okay, then occurrence. If the chance of occurrence of that particular event or particular activity is high, okay, we give a rank of 8, 9, 10. Okay, if it is very low, chance of tsunami is severe, but the chance of occurrence is very low. After 2005, actually 2004, we doesn't have tsunami, right? It doesn't have any major tsunami in coastal areas of India. Okay, so the chance of occurrence is very low or low. So we give a rank of 2, 3 like that. Okay, and another thing when it comes to process, okay, we have to connect it with the capability index value. See, if the capability indices value is less than greater than 1.67, okay, then that process is under severe risk. Okay, unnecessary failures are happening regularly. That is what this indicates. Okay, so based on the CPK value also, you will be able to identify the occurrence ranking also. If the CPK value is less than 0.33, then the chance of occurrence of that particular failure is extremely high. Okay, if it is greater than 1.67, then that particular failure won't occur regularly in that process. Okay, so you can, the chances of occurrence is only 0.00007% only. But if the CP value which you have calculated, if it is 0.33, then you can find the chance of failure of the process itself is 50%. 2 out of 1 times the process will fail. So this is how we can use the capability indices values also to find the occurrence in the FMEA. Then deduction. See, if I am able to detect it, I can give 1, 2, 3. Very rare, absolutely uncertain, then you can give 8, 9, 10 like that. Okay, so this is how you can use this table to allot rankings for these 3 factors.